I wanted to show you an example of how you can use a test to help you as a program evolves. This is still a pretty small problem, but and it uses math, and I apologize to those who don't like math, but it's pretty simple math. But what I want to show you is, because in this class we teach testing, but it's really hard to see how it means anything. And so here's a program that's going to change a little bit as it moves, and we'll see how the testing helps us. So Fibonacci numbers, they're defined as f sub 0, so the zeroth, or the first Fibonacci number is 0, the next one is 1, and each successive number is the sum of the previous two. Okay, what does that mean? So it means, so f sub 2 is 0 plus 1 equals 1. F sub 3 is 2 plus 1, or f sub 2 plus f sub 1, or 1 plus 1 equals 2. F sub 4 adds the 2 and the 1 to get 3. Now we start to get a divergence. Now we see 3 plus 2 gives us 5. And so the sequence looks like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, 43, etc. Okay? So we're going to want to write a program to generate the Fibonacci numbers, but we're going to start out looking at test Fibonacci. Okay? So we need to say import PyTest, and we need to say from Fibonacci, and I have a real problem spelling Fibonacci. I spelled it with an O when I created that file, so we'll just stick with that misspelling. Okay, test, I need to say def test Fibonacci, right? And so we're going to say f numbers equals, come on reading, 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. We'll go up that high. How's that sound? And I meant to make this a list. There we go. So now we want to say index equals 0, and then we'll say for fib in f numbers, and these are not great names, are they? Assert Fibonacci subindex equals fib, and then we have to do index plus equals 1, because I'm trying to step the index in series with stepping through this list. All right, so if this works correctly, then my function will generate this list of numbers, right? So let's see. Okay, get rid of that. This is import PyTest. Oops, and it's giving me a red squiggly because I haven't done anything with import PyTest. So we need to say pytest.main. Okay, so there's our invocation to pytest.main. And of course, if I run this right now, let's see. Test Fibonacci. Cannot import name Fibonacci from Fibonacci because I haven't written anything yet. Alright, so let's go over here to Fibonacci, and for the moment we're going to leave main at pass because we don't care about main. We just want to create this function that'll generate the Fibonacci numbers, right? And I'm going to call this index. It's natural to name it n, and in mathematics it's probably not a bad idea, but I'm going to try to stay away from single character variable numbers. And so because of how the Fibonacci sequence is defined, it's easy to write a recursive function for it, and computer scientists are fascinated with recursion. It has its problems. We'll find out about that in a minute. But so we say if index equals 0, then we're going to return 0. Elif index equals 1, return 1, because those are the first two Fibonacci numbers, right? Else, I forgot the colon, return Fibonacci index minus 1 plus Fibonacci subindex minus 2. And so that's what makes a recursive function beautiful, is it's nice and simple. Okay, we have a special case for the first two Fibonacci numbers, 0 and 1, and after that we just have to add the previous two. And it just keeps decrementing down as we do this. So let's save this out and let's try our test again. And it says it passed. If you're curious about recursive functions, I would recommend writing this code and running it under a debugger to see what happens. Okay, but for right now we're going to say that's really cool. Our Fibonacci numbers work. We've got a test that tests them, and everybody's happy. I said there was a problem with recursive functions, and the problem is how slow they are. Okay, so let's try putting here, let's say 25. Okay, so we're going to print Fibonacci sub 25. So now I'm going to run Fibonacci. Well, that wasn't too bad. Let's try 30. Oh, that took a little moment there, didn't it? And so if I go to 40, that takes quite a while, doesn't it? Takes a long time. Well, if I want to calculate more Fibonacci's than 40, that's pretty slow. In fact, that's really slow. And that's the problem with recursion, is it gets slow really fast, especially something like this where you have double recursion. Wow. And so let's write another test function here. Def test speed. Okay, and we're going to say I'm going to need time for this. Import time. I'm going to say time 0 equals time.time, and that records the time this starts. And I'm going to say Fibonacci sub 40 takes a long time. Let's try 35 and see how long that takes. Time 1 equals time.time. So that's the difference equals time 1 minus time 0. And we want to assert that 40 finally finished for us. Good. So we want to assert that diff is less than 0.5. We want to be able to execute or find the 35th Fibonacci number in less than half a second. Okay, so now let's try our test again. And for some reason it actually runs this while it says it's collecting, and then it runs it again when it says it's running, which is really weird to me. But anyway, we can pretty much see we're going to fail this half-second test here. 8 seconds is not less than half a second. So is there any way to speed this up? Well, I said the problem was with recursion, right? And so it turns out we can write a different version of the Fibonacci function. We're going to call this one Fibonacci recursive, and that way I can keep it around to look at. Okay. And now we're going to do def Fibonacci iterative index, And so now I need to write an iterative version of this. And I'm going to say, actually, I'm going to start off with this same thing here, just for, no, I'm not. I'm sorry. I'm making this up as I go along, so I'm making it up badly. So fibs equals 0, 1. Okay? And we're going to say index equals 1. No, not index. Index is what was passed in. So I'm going to say if index is less than or equal to len fibs, now I got it. Like I said, I'm making this up as I go along. I'm making it up poorly. While true, if index less than len fibs, return fibs sub index, else fibs dot append fibs sub negative 1 plus fibs sub negative 2. And so what that does is that adds the last two Fibonacci numbers and appends them to the list. And now I need to increment index. And I'm incrementing my parameter that was passed in, but that's probably okay. I'm using it in the course of this function. That's probably okay. There's some arguments about that. Okay, I was trying to get ready to go to the temple, and so I had that little diversion about the index, and I looked at it and I thought, that's not right. And the way I've written this program, I do not need to increment index. I just keep appending to the fibs list until it's longer than index. So my rationale about incrementing the index was wrong. I shouldn't increment the index. So, okay, that's not a very clear piece of code. I guess it's not that much longer than that one. But does it work? Well, how can we tell? Best thing we can do is, let's see, I need to I'm importing Fibonacci in the test, remember? So it's calling Fibonacci. And here I've got Fibonacci recursive and Fibonacci iterative. And so it turns out I can just say, so Fibonacci is the same as Fibonacci iterative, and this is the one that'll get tested. So if I run the test, we'll find out if this is generating the right numbers, right? So let's give it a try. Test Fibonacci. Well, that does not look good. It's, oh. I didn't save this. So it's still running the old one. Oh, dear. Let's try that again. Okay, so what happened? We're generating the correct numbers, and so it passed. I didn't have to check it myself. I just ran it against the test. So even though I've implemented a whole new functionality here, I didn't have to check it myself. I just ran it and it passed the test. Now, there's the added advantage that it's also less than half a second to run that, what was that, 35th Fibonacci number, which used to take 8 seconds. Yeah, 8 seconds. So, because the intent of my program didn't change, it's just how it's implemented changed. Effectively, I've gotten rid of Fibonacci recursive, and I've replaced it with Fibonacci iterative. And so my test didn't have to change. I just had to check that my program still passes the test. Now there's one more step we can take here. There's one more way of doing the Fibonacci numbers. It turns out that there's an equation for getting the nth Fibonacci number. And let's see, here it is. Pretty straightforward stuff, huh? Yeah. Well, let's see if this works. So we're going to do def Fibonacci equation index. And now let's see, can we get rid of this guy? Does that get rid of him? No, didn't get rid of that. Okay, now I can cycle through my windows a little easier. Alright, so fib is... Okay, so I'm going to choose this form of the equation here. And I'm going to say ret val just for one. That's the variable I'm going to return. So it equals, and I've already forgotten because I talk too much, phi to the n which is index in this case, and then is it minus? Yeah, minus negative little phi raised to the index, and that whole thing divided by the square root of 5. Come on. Okay, I've got a bunch of red squiggles there because well, I'm going to return ret val. That'll get rid of an orange squiggle. There we go. But I haven't imported math, so I need to import math. So that should get rid of one squiggle. Then I need to define big phi and little phi, don't I? So let's say phi equals root 5 plus 1 over 2. Okay. Okay, so there's big phi. What's little phi? Little phi is phi minus 1. Big phi minus 1. Oh, okay, well that's pretty easy. So, why do I get a squiggle there? Missing white. Oh, I didn't even notice that. Okay. Come on. There we go. No squiggle. Still a squiggle up here because I didn't leave enough lines. But that's all right. Now, so we're now going to use Fibonacci equation. Does this work? It's shorter than either of these, but it's certainly much more complicated in terms of the math. Do we really believe that something that involves the square root of 5 is going to give us an integer? Well, how can I find out? All I have to do is run my test, right? And see if my test still works. Passed and passed. I forgot to save it out. Was somebody going to point that out again? It shouldn't pass, and I'll show you why. Well, you'll see in a moment here. So the problem is, remember when we use floating point numbers, which math.square-root-5 is, there's a slight rounding error because we don't get exactly the square root of 5. We get the closest number to it you can express in 64 bits. So this number isn't exactly 3. It's very close to 3, but in order to make this work, I have to say round. Okay, and now I saved it. Good. And now it passes. So once I had a test that worked, no matter how I generate the Fibonacci numbers, with a slight problem here, it will continue to work. And so that's what the test does for me. It means I don't have to go through and check this equation by hand. I just have to run it and see if I get the right answer. And if you came up with another way of generating the Fibonacci numbers, I don't know of another way, but there might be another way. Again, you could just write the code to do that and test it with this test. And then we would know for sure that it works. So I hope this gives you a little insight into how a test could work. Usually you're not redoing Fibonacci numbers, but you might change something about your program to make it faster. For example, here, I'm calling math.square root here, and I'm calling math.square root here. Well, that's probably slower than it needs to be. So what if I said skew5 equals math.square root 5, and then I replace that with sq5, and replace that with sq5. Did I do that correctly? Well, I don't have to check it. I just have to run the test, right? Still passes. I did it correctly. How about that? And of course, if you're curious, we can just run Fibonacci again. And we can see that value for the 40th Fibonacci number. But that's not, in terms of this function being correct, I now know it's correct because it passed the test. So I hope that helps a little bit.